discussion detail. However, we believe in some cases postcopy is better, and in some cases precopy better. So user should have options in response to their situation. So in this talk, I'm going to first talk about what is postcopy migration, and I'm going to show you a demo which is based on our early prototype. And next, Isaku, he is going to talk about KVM Upstream merge plan. So he's actually now working for it. So precopy live migration copies virtual machine memory before switching the first. And you know, Qemu, then VMware, or a widely used virtual machine monitor takes this approach. And postcopy is the focus of this talk. It copies virtual machine memory after switching the execution host. First, I'm going to show you demo movie. Okay, so a virtual machine with 1 gigabit RAM is live migrated to the right PC, and we use a gigabit Ethernet. And normal is a precopy, and Yabusame is postcopy. And please take a look at Yabusame at first. We start migrations at the same time. And we start, and migration is switch. Yabusame switch the execution host just in 1 second. Is it cool? And data transfer is finished in 10 seconds. And in precopy case, data transfer is still continuing. And finally, the host is switched. So it takes, in this case, 30 seconds. Okay, let's go back to slides. And you can find more demo movies on YouTube. So why precopy takes so long time? Because it first copies all memory pages to destination and copy memory pages updated during the previous copy phase. And at third step, it repeats the second steps until the rest of memory pages are enough small. So second step and third step iterated again and again. So that's why it takes so long time. On the other hand, so if a virtual machine updates memory pages intensively, migration time exponentially increases. And in the worst case, migration never finishes. This is the worst case. So what is postcopy migration? It first stops virtual machine and copies CPU and device states to destination. And CPU and device states is, for instance, approximately 500 kilobytes or so without a VGA device. So that's why we can switch the host within 1 second. And resume virtual machine at destination and copy memory pages basically in an on-demand manner. So when a virtual machine accesses a new memory page and the page is not yet transferred, postcopy transfer virtual machine at the target memory page from source to destination and restart virtual machine. So, however, as you know, by using on-demand copy, it may involve performance loss. So we also exploit background copy. So background copy precaches important memory pages as soon as possible in parallel with on-demand copy. So by using 2 copy threads, we can reduce performance loss. Okay, this is a naive summarize, and by using postcopy, we can switch the host in 200 or 300 milliseconds by using gigabit Ethernet, and the time until all states are removed is basically shorter than precopy case. And as you can see, so pre-copy depends on RAM size and network speed and memory update intensity. However, post-copy always finishes in a period, in a deterministic period of time. So this might be an advantage of post-copy migration. So the question 1, is there performance loss after relocation? Yes, sir. And however, it's not so big. The working set of memory pages is limited in most cases, so the pages are pre-cached as soon as possible. So this graph shows the case of migrating a heavily loaded web server virtual machine, and vertical line shows the average response time from web server. So just after the execution host is switched, as you can see, there is a performance degradation. However, it's not so big. So this kind of performance degradation might be acceptable for most cases. And this graph shows a transferred page offset when I disable pre-caching. So by using only on-demand copy, these memory pages are copied. So this means, so most page offsets virtual machine accesses are limited in this area. So our system tries to detect which part of memory pages are important. And such important memory pages are copied as soon as possible by the background copy. So that's why we can reduce performance degradation. So question 2. So is it useful for dynamic server consolidation? Yes. So it can enable quick and deterministic load balancing. So we experimentally developed a server consolidation system with a Postcopy. And in this system, when data center load is become small, we consolidate virtual machine into fewer hosts and shut down unused physical hosts, thereby reducing power consumption. However, when data center load become high, we distribute running virtual machine into other hosts and assure virtual machine performance. So the graph shows CPU usage of physical machines. So at first, all virtual machines running on the one physical host. However, overloading is detected. So our system quickly relocate virtual machine to other hosts and thereby virtual machine performance as much as possible. And I don't talk detail here. I write a research paper and it's available on website. So please take a look at for detail. However, the results show by using Postcopy for server consolidation system alleviate performance degradation in most cases. So I think it's much more promising in this kind of dynamic consolidation system. Okay, so this is summary of the first half. Yabusame project is a Postcopy line migration for KVM, and my early stage ad hoc concept proof prototype is here, and you can download and you can compile it. However, please don't use it. It's a very early stage. So next, Isaku going to talk about its much better design. We aim to merge Postcopy line migration to the main line. Okay.
Is useful for others. So we'd like to this feature get merged into the upstream. So I'll talk about upstream merge plan. So I already posted a mail to the mailing list, and fortunately I got some feedback. Some have thinking of same idea, or some raised suspicion that this is real application can gain a benefit from Postcopy, but we believe it would be good to it is good to merge this feature into the upstream because we lack experience with real application. So let's bring quality production level quality implementation and let people use it. So we will learn from it. So as long as this feature is introduced as optional feature, we have nothing to lose. So our early implementation is not suitable for upstream merge, so we need to redesign, re-implement it for upstream. So, new implementation should satisfy those lists. It should allow Qemu, KVM features as much as possible. Ideally, it should be work with any combination host target, and it should allow any accelerators, QMTCG or KVM, or it should be work with any devices. But assigned device won't be supported. And maybe VALINux should be supported, vhost should be supported. And also it should allow KVM host features as much as possible. For example, swap, kernel page merging, or transparent huge page, and asynchronous page fault, or core dump, and ptrace, and so on. And overhead. During migration is going on, some overhead is inevitable. But once migration completed, no overhead should remain. And last one is administration change. Administration change must be kept as small as much possible. Ideally, the change should be when you want to use Postcopy. When you start live migration, you just say this migration is Postcopy. Okay, this slide shows our proposal. We don't, please note, we don't stick to this proposal. Right now, we think this is a way to go, but we are quite open to change. There are several points of design. First one is who takes care of putting page contents. I think it should be done with outside of Qemu because and someone suggested it should be handled in Qemu process, inside Qemu process. But I think it should be done outside Qemu process because not only Qemu or KVM related components access GetSlam, but also another component can access GetSlam. For example, core dump. Qemu process may dump its core. So when creating core dump file, Qemu execution is already terminated. For another example is ptrace. For security purpose, some security tool wants to inspect GetSlam from outside guest. Another point is how to pull page contents from the source. My choice is to use the socket of live migration. Maybe it might be possible to use a new connection like block streaming. I think connection and its protocol is not so hard thing. Last point is how to hook GetSlam access. My choice is to introduce a new character device, but there are many possibilities. So far, before looking at each candidate, let's review who accesses guest RAM. QM and KVM components of course access to guest RAM, and vhost also access guest RAM. vhost creates its own kernel thread, and it switches to its address space to QM address space, and it uses QM virtual address to access guest RAM. And another component is core dump and ptrace, and ptrace variants. So I listed for design candidate, inserting hooks or place, or introduce new character device, or backing store, or using swap device. And also Andrea proposed another candidate. He proposed use synchronous signals to notify page fault to QM. But his proposal is basically page fault must be resolved in QM process, inside QM process. So it would be somewhat difficult. Inserting hooks around, this candidate would be most portable. This would work with any combination of QEMU host and target combination. But its bad point is it will be impractical. It would be very difficult to hook vhost, for example. Next one is to use backing device or backing file to guest RAM. Its good point is no new device driver is needed. Its bad point is further optimization would be difficult. And another bad point is some KVM host feature won't work, like KSM or TS transparent huge page. Okay, character device approach. It's good. Introduce new character device to hook page fault, and its page fault is sent up to user process. Its good point is feature optimization is easy, and the bad point is new driver must be implemented. But I have already a first version. Another bad point is some KVM host feature wouldn't work. But Andreas say transparent huge page will work with this approach. But KSM might not. But I hope it wouldn't be so difficult to fix KSM. Another approach is swap device. When setting up guest RAM on the destination, set up as all guest RAM is swapped out. So its page fault is converted to I/O request, and the I/O can be sent up to user space by network block device. Its good point is once its setup is done, everything looks normal. So all KVM host feature works by design, and no new device is needed. Its bad point is future improvement would be difficult, and another bad point is administration. Swap device must be set up, and it is also pointed at that probably a new swap device would be needed, because this swap device accept only swap in. It should never accept swapped out. And also it is pointed out that probably many swap devices would be needed because swap device size is limited, so it is not huge guest RAM size is not rare recently, so it would be ugly. Okay, so my preference is character device approach. So this morning I talked with Ivy, and he agreed to character device approach. At first, he suggested swap device approach is good, but we reached a consensus on character device. But he also suggested that user space character device should be tried at first. I'm not sure it can user space character device can satisfy performance requirement, but I will look into it. Okay. Once there are many feature work, evaluation must be done, and there are many optimization ideas.